Hi, this is Henry Fu from DataOn. Today, I will provide you with an overview of the network ports and cabling for Azure Stack HCI solution HCI 208. DataOn's HCI 208 consists of two or more S2D 528 servers connected to a pair of RDMA-capable switches for high bandwidth, low latency communication. The S2D 5208 servers are 2U high with support for 2 CPUs, 1.5 terabytes of memory, and up to 8 drive bays. With Microsoft's Azure Stack HCI and DataOn's HCI 208, you can easily grow from 2 to 16 nodes for additional compute, memory, and storage capacity with minimal interruption to your production environment. Let's take a look at the network ports on the HCI 208. I will start with the onboard ports. First, we have the dedicated baseport management controller port for out-of-band management. This is an RJ45 port that allows you to access the server's hardware via browser, even when the base operating system is not running. Next, we have two RJ45 10 gigabit Ethernet ports for north-south client and management access. This is typically for access to your domain controller, client application access, and RDP to the servers for management. Finally, we have four SFP28 or QSFP RDMA ports on two PCIe adapters that can support up to 25, 40, 50, and 100 gigabits per second depending on the component selected. These ports can be used in multiple ways with the primary purpose of providing communication for east-west traffic such as cluster storage data, cluster heartbeats, and live migration services. Additionally, these ports can also be used for north-south traffic with separate physical or virtual connections, as I will show you shortly. Now let's take a look at the cabling for each type of port using a 4-node cluster scenario. First, we will illustrate two customer network switches and two RDMA-capable switches from DataOn running at either 25, 40, 50, or 100 gigabits. For simplicity, we will assume the customer switches will have RJ45 and SFP+, and optionally SFP28 or QSFP28 ports available. For the BMC, we will run Cat6 cables from the dedicated BMC port to the switches. For the east-west traffic, we will utilize one RDMA port from each adapter to connect into DataOn switches. Although these are physical network interfaces with physical cables, they will be virtualized into vNICs using Microsoft's Hyper-V Virtual Network Adapter feature to create virtual networks for various traffic configurations and rules. We can leverage these physical connections for north-south traffic, as I will show you shortly. We will now present three options for north-south traffic. Option 1, RJ45. The most straightforward setup for north-south traffic would be to leverage the 10 gigabit RJ45 ports from each server to switches. They would be teamed using switch embedded teaming for high availability. Option 2, remaining RDMA ports. As an alternative to the RJ45 ports, you can use the remaining free ports not used for east-west traffic to connect to your switches for north-south traffic. Option 3. Leverage existing RDMA connections. In the two previous scenarios for north-south traffic, we utilized two physical ports from each server to your switches. The advantage is easier setup, but requires a lot of ports to configure and manage as your environment grows. An alternative to options 1 and 2 would be to leverage your existing physical east-west connections to also communicate for north-south. We can do this by creating additional virtual NICs on each physical NIC, then connect DataOn switches to your switches. This will lessen the number of ports needed on your switches even as your environment grows. Here is the full connections diagram for each of the HCI 208 options. Option 1 with RJ45 for north-south. Option 2 with separate SFP28 or QSFP28 for north-south. Option 3 with switch-to-switch for north-south. For more information about HCI 208, visit our website at dataonstorage.com.